Hey guys, so this video is a continuation of the multiplication of polynomials, but this time we will be talking about some special products. So an expression such as 3x plus 2 quantity squared is called the square of a binomial. This expression can be expanded as two factors of 3x plus 2, and then we can multiply the two binomials by distributing each term of the first binomial to every term of the second binomial. And then we can combine the like terms, and we get 9x squared plus 12x plus 4 as our answer. So there's actually going to be a pattern to this. Notice that 9x squared is actually the first term of the binomial squared. So 3x quantity squared is just 9x squared. And 4 is the second term of the binomial squared. So 2 squared is just 4. And then 12x is twice the product of both terms of the binomial. So 2 times the product, 3x times 2, which is also just 12x. So let's write down this pattern. A binomial squared is equal to the square of the first term plus or minus twice the product of both terms plus the square of the second term. So if we have a binomial squared in the following form, this will equal the first term squared plus twice the product of the terms plus the second term squared. And if the binomial is a difference instead, the formula will just change to this, with this being a minus sign instead. And we call these formulas special products. So let's try a few examples with this shortcut for special products. Again, if you wanted to, you could just expand this expression out as two factors of x plus 2, and then multiply by distributing each term, and we get an answer of x squared plus 4x plus 4, which is correct, but let's try getting this same answer using our special products formula. Since this is a binomial squared of the form a plus b quantity squared, our answer will be the first term squared plus twice the product of the two terms plus the second term squared. So we take x and square it, then multiply the product x times 2 by 2, and then we take 2 and square it. Simplifying this gives us x squared plus 4x plus 4. And for the next example, let's also try answering this using our formula. We take the first term 3x and square it. Then we want to double the product of 3x and 5. And then we take the second term 5 and square it. This simplifies to 9x squared minus 30x plus 25. Again, you don't have to use this formula. If you prefer to expand out the binomial and then multiply, and then combine like terms, that's fine also. Another special product is the product of the sum and difference of the same two terms, such as x plus y times x minus y. If we multiply this out, we get x squared minus xy plus xy minus y squared. The like terms in the middle actually cancel out, and we're left with x squared minus y squared. Notice that the two middle terms subtracted out, and only the difference of squares remains. This will actually be the pattern that arises when we multiply a sum and difference of the same term. So let's write the formula for this special product. The product of the sum and difference of the same two terms is the square of the first term minus the square of the second term. So if we have a product in the form a plus b times a minus b, this will be the square of the first term a minus the square of the second term b. Let's try a few examples applying this special product. So notice that we have a sum and difference of the same terms 6x and 7. We can use our special product formula, where we take the first term squared minus the second term squared. So we square the first term 6x and subtract the square of the second term 7. Simplifying, we get 36x squared minus 49 as our answer. Again, if you wanted to multiply this out instead, and then combine like terms, that's fine also. And for the next example, we also have a sum and difference of the same terms, 4x and 9. So we can use our special product formula again. We square the first term, 4x, and subtract the square of the second term, 9. And this simplifies to 16x squared minus 81.